I was going to comment that my video did actually have a conclusion, and that was on the second to last slide, and that was that the wave function of the universe is a mind, which obviously follows from my two premises. Although that was kind of towards the end, so, you know, it might not have been as obvious as it could have been. So, anyway, with that aside, I'm going to get into the discussion of the wave function, and in particular what you think of what I think of it. So now, I'm not saying that the particle doesn't actually exist before it's measured. What I'm saying is, before we observe it, it takes on a wave-like nature, and it's smeared out in a number of possible states all at once. And when it does this, there's no specific observable values it has. It's spread out in a range of observable values. And so it really is there, it's just taking on its wave-like nature. So I kind of got the impression, and this may be wrong, but I kind of got the impression that you were not really understanding the proper wave-particle duality in quantum mechanics. And I got that impression later on when you were saying that that Sean Carroll quote where you were basically seeming to argue that the particles behave like billiard balls, but that the wave function is just kind of our way of kind of guessing where the particle is going to be at any one time. And that is definitely wrong. That's a local hidden variable theory, and those have been debunked by John Bell. This is with quantum entanglement and so forth. And the particle actually is in several places at once. It's not that we don't know where it is. It literally is smeared out in a number of places at once. Then you measure it with something, and then all of a sudden it takes on one value. So it's not like little billiard balls, and we just don't know what's going on. Now, the second thing I want to get across to was the Sean Carroll quote thing. At first, I thought he was arguing for some kind of hidden variable, like it sounded like he was treating electrons like billiard balls or something, and that sounded kind of crazy to me because that's not really tenable anymore. But anyway, I found the quote online, and it turns out in the question behind it, there was there was a one question, and then there was that answer, then there was a question before that, and it was quite clear that he did not hold that. And so I know what he's doing actually, and it's just kind of irritating, but he's really just recycling positivism into science. What he's saying is we can't actually see the wave function, and so therefore it doesn't exist, and there's not actually anything that's making the electron behave like a wave. And this is kind of, there is no really wave property to it because we can't see the wave property. And this is really kind of ridiculous because with the double slit experiment we can shoot one electron through at a time, and over the course of a couple hours, even though these individual electrons will behave like little billiard balls, the collection of them all will create interference bands on the film in the back. And then when we put a measuring apparatus up by the slits, it won't do that anymore, it'll just create two bands. And so to say that the wave function is not really there or doesn't have any actual physical significance would be to basically ignore the big difference between the sets of bands in the back, the interference bands, and then just the two bands you would normally get from classical particles hitting the film. And so, I mean, this is kind of ridiculous, really. You can't have, if it looks like a wave and acts like a wave and talks like a wave and walks like a wave, it's a wave. You don't get interference bands magically out of thin air. You can't have the electrons can't just like conspire all in their little lonesome to line up just perfectly like interference bands, and then but not actually have some kind of wave nature behind them. So this is just, he's just recycling positivism into this. He's saying that we can't observe it, therefore it doesn't exist. And in this case, this is really blatant because we can't actually observe it itself, but we can see the direct effects of it. It would almost be like saying on CSI that we have a dead body on the ground, and because we didn't actually observe the murderer because he's, hiding somewhere, he never does it when anyone's watching, that there is no murderer because it's just the victim magically becomes dead and has all the appearances of being murdered when on the ground. And that's obviously pretty ridiculous. And furthermore, I will comment that there are quite a number of scientists that hold a whole wide array of real interpretations of what the wave function is. What Sean Carroll was arguing was sort of the agnostic position, which is basically the equations work by magic and don't ask why they work, which is, come on, they have to work somehow, right? they don't just behave like waves all by themselves for no apparent reason if they're not actually, if there isn't some kind of wave behavior behind them. Alright, and he basically have to lump in a whole lot of scientists and say that none of them understand quantum mechanics either, which is just not the case. So that does not hold water. The last thing I want to get to was this accusation of quantum quackery, and I got the impression by reading some of the comments, this wasn't in the video, but this was in the comment section, that a number of people were thinking that somehow I was sort of in the new age, what the bleep do we know line of thinking, and that is not true at all. All I was doing was making an ontological observation that, you know, if we have a mind that observes something and then we have a fundamental physical interaction, if we're going to get around substance dualism, then we're going to have to equate both of these fundamental interactions. You know, the eye observing a quality of some sort, like a redness or blueness or whatever, that's fundamental. You can't cut the eye in half. You can't cut, red and blue are irreducible. And then at the same time, you have whatever the fundamental physical interaction is, which in this case is the wave function collapse. And so now, if we're going to get around substance dualism, we're going to have to assume that these two fundamental interactions have to be one and the same interaction. And if we don't do this, then we're going to have two different substances with different fundamental interactions, and hence substance dualism, which I think we all agree is untenable. So that's all I was getting at, that the wave function, if we're going to get around that, if we're going to have monism, the wave function collapse has to be ontologically identical with observation. And I think I actually mentioned this very specifically in 2 points in the movie, that a non-mental piece of measuring apparatus could do this just as well as a mental person, a mind. So that's not the case that I'm arguing that the world is dependent on our minds or anything like that. Now, of course, on the big scale, I was arguing that it was dependent on God's mind, but that's different because, we're not in control of it, and as such, the external world is mind independent to us, and so we can observe it. It'll behave the same way it always does from day to day. We can do science in it. It'll have testable laws and so forth. So that's all I was getting at. It was just an ontological observation, and I'm not buying into the idea that we can somehow change the world with our mind and go into the whole Deepak Chopra approach and get off on sort of this quantum mysticism. And if that quantum mysticism really was valid, we'd have this situation with us being able to change the definition of the Schrödinger equation, which would then contradict quantum mysticism in itself. So that would be self-contradictory. So that I'm just saying that because I know a lot of New Age people are probably going to be attracted to my video. So just pointing that out to you guys once you see this. So, all right, that's it. Bye.